Hello, everybody. Today, I'm going to present statistics for data science, what you should know, and why. So first of all, let me introduce myself. My name is Gabriela de Queiroz, and I'm a developer advocate at IBM. I'm also the founder of Our Ladies, and I'm going to talk about statistics, and then in the end, I'm going to talk a little bit about Our Ladies. And if you're interested in learning more what my team is doing, you can check the link below on my slides. And then if you want to know a little bit more about Our Ladies, there is a link on my slides as well. These slides are a little bit different from the one that I made available on PDF on the web page. So probably later on, I'm going to update there as well. So the agenda for today is I'm going to cover 5 main topics, and the first one is to know your data. The second one, it's correlation and causation. The third one, it's A/B test. And then the fourth, statistical models. And then the last one, probability. And then we have a bonus, which is I'm going to talk about Our Ladies because that's along statistics, it's my passion. So let me start giving you some context where I'm coming from and what is my background. So I'm from Brazil, from Rio de Janeiro, so the picture in your left. And in Brazil, I studied statistics in college, and then I did my master's in epidemiology. And during this time, I was working there as an epidemiologist / statistician on air pollution data. So it was inside a lab inside the university, and then I was analyzing air pollution data and the effects of air pollution on people's health. Then I moved to California to study statistics again, to do a second master's, but now in statistics. So I did that master's, and then I decided to move to the industry. So I came from like being a statistician to becoming a data scientist. So I moved from also like research to the industry. So it was a big move in several aspects, not only about the language, like the English, coming from Portuguese to English, and then coming from like a research environment to in the industry environment. So as I moved to the industry, I worked in different startups and several companies. And I was 99% of the time, I was the only statistician. So I had other data scientists, but they had different backgrounds. So, so I was only the only data scientist in the company, and also the only statistician. So it was a kind of like a lonely journey in some companies. So even though I was hired to build models and develop algorithms, run experiments, the big part of my job was to build a knowledge base around the statistics and best practices to empower other people in my team and in the company. So it would be very common for me like to write about statistics and what are some use cases and why I'm making the decision or the other based on some statistical knowledge that I had. So today I'm going to focus on the top 5 statistical concepts that you should know to work with data. And this talk came to me as, I still do, but like I mentor a lot of like aspiring data scientists, and the thing that they tell me, it's like, oh yeah, so, to become a data scientist, I need to know machine learning and how to use the algorithms. And then I say, yes, you have to know that, but you have to know a little bit more than that. You should know some basic statistics so you can understand what the algorithms are doing in the back end. So that's how I started thinking about, like what are the top 5 that I consider the top 5 statistical concepts that you should know to work with data. So the first one is to know your data. You should know what are the data sources you have available, what kind of variables you have, what are the meaning of the variables. So you should have a general overview what you have available. It's also like very common for a data science to get hired and to work in a company where they have a bunch of data, but they don't have like any explanation what the variables mean. So you get hired and then you start digging into the problem, but you have no idea what you are dealing with. So that's the main concept. You should know your data, all the data that you have available, all the data sources, the meaning, the type of the data, and all that. So some ways that you can know your data besides knowing the meaning, definitions around, and the data sources available, it's doing like summary statistics and plotting your data. So you could plot your data using histograms, bar plots, scatter plots. But this is the tricky part. So summary statistics alone or numbers alone are not enough. And I'm going to show you some examples. So there is a very well-known example that's called Anscombe's quartet, that it's 4 different data sets, and for the 4 different ones you have the same summary statistics. So you have the same mean, the same correlation, so the same numbers, but then when you plot them, they are totally different. So you can see on the plot that they are totally different data sets, even though they have the same summary statistics or the same numbers. Another second example that I really enjoy, it's a more recent example called the Datasaurus dozen. Which is a collection of like data sets, and there is an animation going on, which is pretty cool. Like, so you plot your data, and then you have the same kind of like the same summary statistics for all the I think it's 13 data sets. Again, numbers alone doesn't tell you the whole story. If you want to take a look at this paper, this data set, there is a link on the bottom. And if you want to play around, there is also our package. So you can play around with this data and plot them. So before jumping into any analysis or running any sophisticated model or algorithm, make sure to plot your data, because a lot of things that you can find plotting your data, you cannot find when you are running your model, or you are going to miss very important points if you don't plot your data. So if you have no idea, like I have no idea where I should start when plotting, I really like this chart suggestion. It was developed in 2006, and it's been around, so 12 years. It's been around for 12 years. And I like this chart, because it gives you some, if you want to do like a comparison, these are the kind of plots you should use. Or if you are looking for like relationship or distribution, these are the kind of plots that it's recommended for you to use. There are other variations of this main chart with like more animations and all that, but this is a very good start if you have no idea where you should start. So talking about plots, it leads me to my second topic, which is correlation. And that's my second important topic. And if you don't know what is a correlation, let me define what correlation is. So correlation describes the strength of the linear relationship between 2 variables. So it's a value between -1 and +1. So you can have a positive correlation, as you can see in the first plot. You can have a negative correlation, as you can see in the second one, or you can have no correlation at all. And the extreme, the number, if it's either -1 or +1, the strong this association. So let's go through an example, because I think examples are interesting for us to think about. And so let's go through this one. So this one is a plot where I have the ice cream sales and the number of shark attacks. So as we can see here, as the number of ice cream sales increase, the number of shark attacks increase as well. So cool. So can we say that ice cream sales cause shark attacks? So no, we cannot say that. That's wrong, because there is a third factor that it's called a confounder factor, that it's making one and the other to increase. So maybe it's summer, so the season is the third factor. So it's summer, so that's why the sales of ice cream is increasing, and because it's hot, more people are going to swim, and that's why the number of shark attacks is increasing as well. So another interesting example about correlation and causation and all that. So it's a fun example where you have an observer that it's looking what is going on outside his house, and he's looking at all these people with umbrellas and the rain, right? So they are with their umbrella, and then it's raining. Then this person thinks like, umbrella causes rain. So, right? So he made a conclusion that if you have an umbrella, it's going to rain. So the next day, it's a very sunny day and very hot, summer. And then he's like, oh, I wish it was raining. But I remember from what I saw yesterday, if I go outside with my umbrella, then it will start to rain. So then he went out with umbrella expecting the rain, but then there was no rain. So that's a typical example that correlation does imply causation. So causality indicates that one event is the result of the other event, where correlation between two things can be caused by a third factor, the confounder, that affects both of them. So you are probably asking yourself, is there any time where correlation implies causation? And the best way to establish cause and effect is doing a controlled trial, as known as A/B test. So that leads us to the third topic, which is A/B testing. And A/B testing, you hear a lot about A/B testing, and especially from people coming from academia and moving to the industry. This is kind of like a new term, right? So you don't study A/B testing in school, at least I didn't. So let me define what A/B testing is. So A/B testing is an online experiment where you are testing a new design. It can be like a website design, or it can be a new machine learning model, or it can be any feature that you are thinking of launching. So in this example, we have like one version on the website where you have a green button, and then you have a variation of that you have a red button. So you're going to compare those two. So A/B testing, it's nothing other than hypothesis test. The concept is very similar, and all the steps that you have to follow are also very similar. So if you don't know about hypothesis tests, it's just a way to decide whether the data supports one point of view or another. So then you are wondering, like, how do I set up an experiment? So like, let's say I want to test something. So how do I go about setting up an experiment? And I'm going to talk more about like, on the industry side of things, less than if you are doing a laboratory experiment. So how do you set up an experiment? So the first one is you have to define the goal and form the hypothesis. So the goal would be, I'm interested in see if the change is going to affect, or if I should change something and launch my product. What is the goal that I'm looking at? looking for. And then what is the hypothesis? So the hypothesis would be, changing the color of the button will increase my click-through rate or the number of signups on my website. So again, the form of a hypothesis comes from statistics. So the concepts around hypothesis tests and significance level. So the second piece is about identifying the control and the treatment group. So how are you going to split these two groups? Are you going to split by user ID, or are you going to split using any other criteria? For the second piece, it's like you have to identify what are the key metrics. What are you trying to measure? Are you measuring click-through rate? Are you measuring signups? Are you measuring time on site? What are you measuring? What do you want to improve? And then the desired improvement. So do you want a change of 1%, 5%, 10% increase, for example? And this improvement, this percentage that I talked about, is related to statistics and is known as effect size. The next one, it's like, how much are you going to have in each group? Are you going to do a 50-50% fraction for both groups, or are you going to do a different split? So you have to think about that as well. And then once you decide that, you have to decide, how long am I going to run the experiment? Am I going to run the experiment for 10 days, a week, 2 weeks? How much time? So the amount of time that you are going to need, it's based also on sample size. So another concept from statistics. And then once you ran your experiment for a certain period of time, like as I mentioned, a week, 2 weeks, 10 days, you have the data that you need to analyze the results. So that the last piece would be to analyze the results, would be, for example, for you to do some statistical test, some proportion test, or any other test that you are interested, depending on your goal. And you can do this using R, for example. They have several functions in R that you can use to analyze the results. And analyze the results working with data also leads to my next topic, which is statistical models. So statistical models are like a mathematical function. And the idea is you have a response variable that sometimes it's called outcome. And then you have all the other variables that you are trying to explain. So the explanatory variables. So you have all your response and all the explanatory variables. So for example, of models, you can have like time series. It's a classical statistical model. Then you have like linear regression, you have nonlinear regression. Here, just to show you a few, but there are some others. Let's go through another use case. So like, let's say you were hired to provide an advice on how to improve sales of a particular product. So the goal is to develop a model that can be used to predict sales based on 3 media budgets. And this is an example from a book that I really enjoy and I really like and I recommend. And I have some resources in the end for you to take a look later. But this one, it's a book that I really recommend it, and it's free. So we have a data with the sales of the product and all the budgets for the 3 different media. So you have TV, radio, and newspaper. So again, let's define output variables. What is the output variable? So the output variable is the sales in thousands of units. And then the input variables is it's dollars, thousands of dollars. It's what is the budget? So the sales for this particular product that I'm interested in is a function of all 3 advertising budgets. So let's say again, you were asked to suggest a marketing plan plan for next year that will result in high product sales. So what kind of information would be useful to provide? So how would you approach this problem? So the first question that I would ask is there any relationship between the variables? So is there like any relationship between the advertising budget for the three medias and sales? So the first goal would be to see if there is any association between them. Then the second one would be if there is a relationship, how strong is this relationship? Then the third one would be, do all three medias contribute to sales or just one or two? Then the fourth question that I would ask is like, how accurately can we estimate the effect of each media on sales? In other words, is for every dollar that we spend on advertising in TV or news or radio, by what amount the sales will increase? And then the fifth one, how accurately can we predict future sales? So for any three of the different advertisings, what is the prediction for sales? And what is the accuracy of this prediction? And the other one is like, is this relationship linear or like a straight line that you can model as a linear regression? Or if it's not a straight line, is there a way that I can do a transformation to make the prediction of or the response linear so that I can use a linear regression? We could be using a different model, but like in this case, I want to try to be as simple as possible. So we could answer all those questions by setting up, for example, a multiple linear regression, which is very easy to run, and you can make interpretations around the results of the model. So why am I going through all these steps? Why you can not only get your input, into a black box and get some output? I think the main idea, like for me, and the main reason why I would do that is because of interpretability. So a lot of times, depending like where you work and the kind of problem you are dealing and the type of like people are around you, like if they sometimes like your boss or the stakeholders, they want to understand what you are doing. So running a black box algorithm where you cannot explain what is going on, it's not going to be enough for them. So like let's say again, you are working with doctors, or they want to understand what you are doing and how do you explain what you are doing, or how do you explain what is the meaning of the output that you are getting. So interpretability, it's a main point for this kind of statistical model. So another thing that I've been thinking about a lot is like, with all this privacy stuff going on, GDPR and transparency, I wonder if we are going to a direction where the models that we use has to be very transparency, and you have to be able to make interpretation from them. So that's something that I've been thinking about, and I don't see a lot of discussion around that in the data science community. Maybe it's something that will come up in the future, but anyway, it's a trade-off. So and again, like sometimes, like just to give an example, there was a project that I worked on where I was trying to run a click prediction model, and then I had two different models. I had a random forest and a logistic regression, and even though the random forest was performing better than my logistic regression, I decided to go with logistic regression for some reasons. First of all, when I was deploying my model in production, the response time of the algorithm was taking too long to run and to get all my predictions. And because I I had to run my model in milliseconds to get a response back, and then because it was real time and a lot of like, we have a lot of limitation in terms of like response time. So I could not run random forest in production. So I had to go with logistic regression because it was faster to run, and also we were using Scala in production, and we didn't have a way to translate my random forest from R to Scala. So logistic regression looked as the best that we could do. And it was pretty good. So you have to think about all the trade-offs and what kind of situation you have. The last topic is probability. And probability it's one of the main keys here, because a lot of algorithms that we use in machine learning, like naive-Bayes, logistic regression, KNN, LDA, decision tree association rules, and the others, they all have probability in somewhere in their construction. So probability plays a main role in the machine learning environment. So you don't have to go very deep into probability and to know, you don't have to know all the how to prove things, but you have to have a grasp of probability and the concepts and the basic construction. But most of all, like, you know, all the 5 concepts that I talked about, most of all the 5, I think for you as a data scientist, for you to differentiate yourself from others, and also like with all these new technologies coming up, like AutoML or all the other automation techniques that are available right now, the only way that we can differentiate ourselves from the machines and automation is the critical thinking. So, you know, it doesn't matter what technique you choose, the most important skill is the critical thinking. So it's like asking questions, asking the right questions, and use your data to answer those questions. So what kind of questions do I have? How do I go about answering those questions with the data? So that's something that the computer cannot replace, and that's a very important skill to have. So before jumping into questions and all that, I would like to move to my bonus point, which was, before that, let's go through the resources, and then I'll jump into the bonus. So some resources for you, if you are interested in learning more about statistics, these are like my main recommendations. So the first one is the Open Intro Statistics, which is a free textbook, and it's very good. It's free, you can download, they have PDF, they have like several examples. And then the second one is the one that I mentioned before, is the Introduction to Statistical Learning with Application in R. It's also free. They have theory and then application in R. Theory, application in R. So if you are the kind of person who likes more like application, this is a book that I also would recommend. And then the other 3, the books, they are not free, but they are also very good. So the Probability in Statistics by G. Groot, it's I would say it's not very beginner friendly, but it's you know, it shows a lot about probability and all the reasoning behind and proofs and all that. And the other one is the first course in probability by Sheldon Ross. If you want to go deeper into probability, also this is the book that I would recommend. The Practical Statistics for Data Scientists, it's a more a beginner-friendly book, I would consider. So if you're interested, you have that option. And then if you don't like books at all and you prefer, you know, online classes where you have a video lecture followed by exercises, I highly recommend Data Camp. And I'm just showing 4 different courses related to statistics, but they have like tons of courses there in R, Python, SQL. So for Data Camp statistics, I would recommend the correlation and regression, and then foundations of inference, introduction to data, and exploratory data analysis. Again, they have like several other courses over there. So make sure to check them out. They have a free version. Some courses are free, some courses you can take the first chapter for free, and they have a subscription that you can pay and then have access to all the courses. So let's jump to Our Ladies, because I think it's such an important part of my work and important part of what I do. So I'm going to give you an overview of what Our Ladies is, and so let's jump into that. So if you don't know about Our Ladies is a worldwide organization that promotes gender diversity in the art community via meetups and mentorship in a friendly and safe environment. So the mission of Our Ladies is to have more women, non-binary coders, developers, speakers, leaders, so more gender minorities developing art packages and being part of the art community. So as of today, we have over 100 chapters all over the world. We have a lot of chapters in the US, South America, Europe, Africa, Asia, Australia. So if you are interested in learning more, and if you want to see if there is a chapter in your city, you can check our website. It's ourladies.org, or you can check this shiny app that we made with some numbers around each chapter, so you can check if there is a chapter in your city, and then it links you to the meetup page. But if there isn't a chapter in your city and you are interested in starting your own chapter, the best thing that you can do is to send us an email. And you can send us an email saying, oh, I'm interested in starting a local chapter in my city because there isn't one. So you can send us an email, and then we'll send you through everything that you need to start your own chapter. So you get what we call the starter kit. So it's a tech infrastructure. So it's everything that you need to get set up. So you get some tips on how to organize events. We have code of conduct. Actually, we have in Portuguese as well. So English, Spanish, and Portuguese. You get an Our Ladies email. You get invited to a Slack channel. You have access to a lot of like training materials that other meetups or other groups use for their meetups. You have financial support to cover the meetup, so you don't have to pay for anything. Everything is for free. It's free. And also, like, you be part of this incredible that I call family, and you learn a lot of art and things related. You have unlimited support, and you meet other Our Ladies, and much, much more than that. Like, we have a project going on, events all over. We have conferences that we talk, we go, and we have book clubs. There are a lot of things going on. So yeah, so come join us. And before, one last thing before I forget. If you're interested in talking to me for, I think it's 25 minutes or half an hour, I don't remember, you can check the one-on-one session in the IBM Community Day website, Be My App website, and then you schedule a one-on-one session. And that can be, you know, we can talk about career in data science, how do you enter into the data science, if you want to talk about community, statistics, machine learning, it's open to anyone. I'm going to open more slots because I opened a few and they are all booked, but I'm going to add more slots. Again, I would like to thank you, and if you want to get in touch, My website is k-ros.com, and then Twitter, G.D.Queiroz. And if you want to know more about Our Ladies, we have a website, and we are very heavy on Twitter. So we use Twitter a lot. So you can check Our Ladies Global on Twitter. And I want to show you just the website. So this is the Our Ladies website. So in the main page, you can see like all the locations, and this will link you to the meetup page. So like, let's go here for San Francisco, for example. This is the page for San Francisco. You can see all the past meetups, what was going on, what is coming. If you want to know what are the events going on in all the chapters, we have these events option, events on the menu where you can see the events on from all the Our Ladies meetups. So you can see everything that is going on, and kind of like a small description of the event. What else? We have the Our Ladies directory, which is pretty cool. And if you are looking for speakers to your conference or event, you can go over here and find people that are available to speak. So if you go to United States, it's going to open a new window with all the speaker availables for that region. It's taking a while, but this is something that we are working on. Let's see what else. We have the Twitter, GitHub, we have a blog. We also have a GitHub repo, which I can show you right now. So on the GitHub repo, we have all the presentations from all the meetups. We have projects that we are working on, like the dashboard that I showed you in the presentation, which is this one here. This is the code from this one. It's on the GitHub repo. It's here, Our Shiny Lady. We have some also like issues. If you want to contribute to the package, to the Our Shiny application, you can go over here. We also have a meetup our package, which is our interface to the meetup API. So you can use to access statistics and numbers from the meetup.com. Also feel free to play around and to open issues or working into pull requests. Let's see. So yeah, so this is the directory. So we have a list of everybody that signed up to be in the directory. So you can go through here and then see, this person has interest in cognitive psychology, data visualization, and how you can get in touch with this person. So that's pretty cool. And let's see. I don't have anything else for now. So let's see if we have any questions. So someone asked about the resources. So I'm going to show it again. Let's see if I can do this. It's over here. And I'll make sure to make it available later for everybody to download this one as well. Another question that we have over here. Okay, I think it's not possible to schedule a one-on-one session. Yeah, so I'm going to open more slots so to make sure that I can accommodate everybody. Let's see. Oh yeah, we have a data science community, the community.ibm.com/data science, which I can show you a little bit. If you go over here, we have a lot of interesting resources, and we have, you can participate, you can ask questions. There are articles over here. Also, I don't know if you heard about Call for Code. Call for Code, which is a huge initiative by IBM and other partners. So you can register for the challenge, and there are a lot of information in this website. And I gave a tech talk a while back ago on how to register and go through all the steps that you should go to be part of this challenge. What else? Let's see what else we have here. Question about t-testing statistics. We can take that offline because this is another lecture. Yes, there is an online course from Stanford. Yeah, that's a very good course. It's based on the statistical learning with application in our book. I totally recommend this one. Let's see. Oh, thanks for Our Ladies. Yes, so definitely check Our Ladies out. Check Twitter. Go to our website, see if there is any chapter in your city. If there isn't, and also you have the option to join the Our Ladies Remote. So the Our Ladies Meetup, the meetup, the Our Ladies Remote has a web page, which I think is, let's see if I can remember for the top of my head. It's Our Ladies-Remote. So they also have a Slack that you can join, and they have events every month, either through Slack or using Zoom, like a webinar based. Let's see what else. What does R stands for? That's a good question. So I don't remember actually. So that's a good question. I don't remember why R, actually. I don't think there is a, yeah, I don't remember. If someone knows or remembers, please send a message here on the chat. Can you send the link of the Stanford? Okay, yes. Let's find over here. We can find together. So I think it's a recording. I don't think they are doing the class anymore. So this is the class that I was talking about. It's very good. I totally recommend it. A while back ago, when they were doing live, so 2014, is it possible? Yeah, 4 years ago, maybe. We did this course with Our Ladies in San Francisco. So we did all the course together. So we would meet weekly to go through the lectures together, and then ask questions, and then go through the exercises together. So we went from the beginning to the end with the group. So again, it's very good. So from what I see over here, it's not live anymore, but you can still do it. So I'm going to paste this to the chat. Yeah, Udemy has also classes. Udacity has a bunch of classes. If we're interested in, oh yeah, so R is presumably enabled. 2 main developers are being, wow, okay, yeah, that's. I'm sure we have some of the history somewhere. Let's see. So this is the main R website. So there is a bunch of information about R over here. If you never used R, I would recommend you to install RStudio. RStudio is IDE for R, and they have like a bunch of good resources and add-ins and functions, and I don't know, they have so many things that I don't even remember all those from the top of my head, but like you can check over here all the tools and functionalities that they have. They have a bunch of resources like webinars and online learning. They have in-person training, workshops. Also, like if you're interested in like doing deep learning, they have interface TensorFlow. They have the Keras package. Also, they have a bunch of resources here about TensorFlow. in our, let's see what else. Someone is recommending a course in statistics from edX. That's good. For Python, there is a book using statistics and Python. I think it's what's it called? I don't know if this is ThinkStats. There is a very good in Python that I'm blanking. Maybe it's this one. Yeah, this is the one by Alan. Yes, this is, if you are a Python user, make sure to check this this book. And I think you can download here for free. So yeah, make sure to take a look at this one if you are more like Python person. If you are also like interested in like data science boot camps, there are a few, especially here in San Francisco, but there are some boot camps that you can do online. We have Springboard, for example, that they have an online program, and you don't have, it's not an in-person, so it's everything is online. All the classes are online, but then you also get to have a mentor. So you have a one-on-one mentorship. So we have a call with a mentor. I think it's weekly for half an hour, where you can ask any questions, like from data science, statistics, machine learning, or any technical question to how do I get a job as a data scientist? Like, how should I prepare for interviews? Can you take a look at my resume? So it's a way for you to get in touch with data scientists in the industry. So Springboard is a good bootcamp as an online resource. Let's see. Yeah, I agree with Joe's. You don't have to go deep into statistics, like the theory, like the very heavy math theory, but it's good for you to have a general understanding, like the whys and why not, and why you can do this, why you cannot do this. So if this makes sense, or right, so to have a general grasping of probability, it's important to have. Also, another point here that's very interesting, if you go through data science interviews, like 99% of the time, they are going to ask you probability questions. So, like, that's my experience. Like, all interviews, they have some kind of probability question. Like, they have examples where they guide you through, let's suppose you are, I don't know, in a corner of like a street, and then you see cars passing by. So what is the probability? So like they have examples, and then the probability is in some sense attached to the example. So another question from Winnie is more advanced statistics necessary for understanding machine learning? Depends on like what you call about advanced. Again, you should have a basic understanding of statistics. And if you want to know what is going on under the hood on the machine learning algorithms, then again, you should know probability for sure. Probability, it's the basic. And then, yeah, linear algebra calculus, multivariable calculus is important. I agree with that. If you are going into data science and also using R, you can check this book, which is also free. The R for Data Science by Garrett and Hadley Wickham. It's a very good book for doing everything, like from like data visualization, data transformation, data analysis, working with projects in RStudio, importing the data, working with dates, functions, how to write functions, and some basic on modeling, and also like how do you communicate your results. What kind of statistics test it's necessary to understand as a data scientist? So I would say like proportion and like t-test. T-test is the main one I would say. Yeah, it's tricky to say because it depends on like what is the problem that you are working on, what is the goal, what is the business goal, and what is the data that you have available, what kind of questions are you asking. So it's hard to say, you need this or that. It totally depends on the case. But like the t-test, it's a general throughout the community and the companies. Do I need to be good in math in order to be a good data scientist? Also depends. Like you have to understand, you have to have some basic math, but you don't have to have a background in math, like in pure math, to be a data scientist. And data science is such a broad area that like maybe one person, it's like as a data scientist, they are developing new algorithms. So that person should be good in math because they are developing and they are doing like manipulations to develop a new algorithm. Where if you are a data scientist that work with like SQL, where you are doing more like exploratory analysis, then some descriptive statistics is enough for you. So again, it depends on where you are in the spectrum. And I personally don't like the term data scientist because it's so broad and yeah. So I think in the future, we are going to have specializations, like the same as we have like software engineers. So we have like a front-end engineer or a back-end engineer, or you have someone that is more responsible for creating applications. So I would say that data scientists will go in that direction. So you have like a data scientist who is specialized in data visualization. Then you have like a machine learning engineer that is going to be creating new algorithms, or you have a data scientist that it's more like a research type of a scientist. So yeah, so let's see where things will go with the data scientist terminology. And if you are not part of Twitter, I would recommend for you to browse around Twitter. And we have, for the R Ladies for example, we have a huge community. And if you have questions, Twitter is a good place to ask questions as well. Or if you want to get in touch with other people, Twitter is also a good media. So another question, should a data scientist know both Python and R or focus on either one? I would say choose one and be good on that one. Because it's if like, let's say for myself, I've been using R for a long time, for over 10 years. And it's more like natural for me to use R for sure. But if I have to migrate to a different language, Python, for example, it's going to be easier because I already know R and all the functionality about R. So my personal suggestion would be choose one and then learn that one well. What was the code site that you shared earlier? Which one? The code site. The code site. I don't know, Terence. I don't know which site are you talking about. What is the code site? I talked about data camp. Oh, data camp, yes. Oh, call for code. Oh, okay, call for code. Okay, so let's go back to call for code. So call for code is this huge initiative by IBM where you can register for the challenge. So it's callforcode.org. You can come over here and then register to the challenge. When you register, it's going to pop up a new window, and then you can register with your name and all this information. And if you want to browse around and see what's going on, like there are a lot of resources to make you to give you some starts, like how do I approach this problem? So we have 6 different areas. So for example, the understand, analyze, and predict health and nutrition needs to improve services with data science. So the data science one is one area that I'm leading with my colleague Agustina, who is going to talk in a few minutes. So you have several code patterns here, so you can check those out. It's like code and some code and explanation. So let me make sure, call for code. So callforcode.org is the website. How important is Kaggle competition for practicing news? I think it's worth checking Kaggle, but make sure, yeah. So make sure to get something that is already been done, and you have support there as well. We have some forum, we have data to play with. So cool. So I'll make sure to make these slides available. And if you have any question, feel free to reach me. I'm going to open more one-on-one session. You can check my website, Twitter, email me. Thank you very much for attending. And I hope to see you next time. All right. Thank you. Thank you, everyone.